Welcome to our class on thermal use efficiency. Thermal use efficiency. In the previous class, we tried to understand radiation use efficiency. Now, what is the thermal use efficiency? Thermal use efficiency is a combination of 8 most important terminology which I used in several of my students' experiments and my own experiments. Crop weather relationship studies in Rabi sorghum. There we have studied these thermal use efficiency. The full 8 parameters we have studied in addition to radiation use efficiency. In my own PhD thesis also I have calculated in the last class I showed. So, studies on the influence of macro and micro meteorological factors on growth and yield of soybean by Radha, Krishna, Murthy, myself. So, there also I have studied these things. Now, in this class we are going to understand starting from GDD, HTU. From there we study 8 and then I give the conclusion. Before that, why we should study the thermal use efficiency? Because most of the plants, the growth, the metabolic activities and the development. In most of the books you will find growth and development. No, here growth, metabolic activities and development. That's what we found after working with several of my students. These things are also being worked out by my own students. The practical manual on Agromet by Radha, Krishna, Murthy and my beloved students. Here we have written these things here also. What I am interested in impress upon you. We start from the GDD. What is GDD? Growing degree days is T maximum plus T minimum average by 2 minus TB base temperature. So here the first equation is growing degree days. T maximum plus T minimum by 2 minus TB degree centigrade day is the units. Now what is the heliothermal units? Growing degree days into bright sunshine hours. So we get the heliothermal units. What are the units? Degree day hours. Degree day hour. We get it. This is not divided by into. That's why degree day hour. Here degree centigrade day. Degree centigrade day is the units per growing degree days. These bits will come. You are going to calculate even for JRF, SRF, net. These equations we have to be at the by heart. You should by heart not only the units but also the equations. Now, what is photothermal units? First one is growing degree days, second one is heliothermal units. What is photothermal units? GDD into day length. GDD into day length. So, what is GDD units? Degree centigrade day. Hour. Day length is also in hours, like sunshine hours. Now, what is the fourth one? Heat use efficiency. What is heat use efficiency? Total dry matter divided by seed yield in kg per hectare divided by accumulated heat unit. That is the GDD. What are the units? Kg per hectare per degree centigrade day are the units. Okay, that is the heat use efficiency. Photothermal use efficiency. P small t thermal use efficiency. Photothermal use efficiency. What is photothermal use efficiency? Photothermal units we have calculated. GDD into day length. GDD degree centigrade day length of the hours. Now similarly, total dry matter divided by CD in kg per hectare divided by photothermal units, we get the photothermal use efficiency. In addition to this, we try to understand here the sixth one. Heliothermal use efficiency. Heliothermal means GDD into HTU. Heliothermal units. Okay, heliothermal units we divide with what? Total dry matter divided by seed yield per hectare. Total dry matter. If a crop is there, for some huge amount of total dry matter we get it. Divided by seed yield. Much of it is much less is the seed yield. So total dry matter divided by seed yield by HTU we get the heliothermal use efficiency. The units are kg per hectare, degree centigrade per day, hour. So thermophoto ratio, degree day divided by day length. Degree day means growing degree day in degree centigrade day, and day length is also in hours. So we get what we get here is the thermophoto ratio. Finally, we should know the eighth one. This is also equally important or very important. Phenothermal index, PTI, growing degree days divided by growth days. Why? What is the growth days? Starting from germination to emergency to harvesting. Growth days we take it. That's why GDD is again degree centigrade day. and number of days. So these are the units of phenothermal units. Why we should study as agrometeorologists? Because I told several times that the responsibility of the agrometeorologist in the inevitable circumstances of climate change and food security under several situations, we are the people who are going to address the intricacies involved in the food security. So therefore, not only radiation use efficiency but also thermal, environmental thermal use efficiency. We should know it. As agrometeorologists, we should know certain basic things. What are those? I would like to impress upon you. After radiation use efficiency and thermal use efficiency, number one, it is well known that the weather at sowing time determines the selection of crop variety. Weather at the sowing time, early onset of monsoon, late onset of monsoon. So, what is the weather? That determines the variety. That agrometeorologist should determine the day on which farmer should go for sowing window, we call it. If conditions are favorable during the first phase, that is germination to establishment, the crop gets good start. Okay, like a 100-meter dash, the good start should be there. Thereafter, the intervals of clear weather are required for interculture and weeding. We, as agrometeorologists, should inform to the weather forecaster when are the possibilities of clear weather for interculture and weeding. So, based on the weather forecaster's information, we should pass it on to the farmer. Then, during the period of rapid vegetative growth, water requirement and need for sunshine for photosynthesis are very essential. Again, I am telling, during the period of rapid vegetative growth, water requirement and need for sunshine for photosynthesis are maximum. So, we should ask the weather forecaster, sir, are there good days of maximum possible sunshine? Because water we want, if water we get from the rain, otherwise supplementary irrigation we get it. So then follows the period of flowering and reproduction with a little vegetative growth. During the flowering and reproductive stage, there is a little vegetative growth. During the period of flowering and grain formation, clear weather and minimum cloudiness are favorable. Then we should ask the weather forecaster, when are the clear days, clear cloudless days, clear cloudy days, non-cloudy days, clear weather days are available, we should ask. Otherwise, what will happen? The cloudy wet weather during this period can ruin the otherwise a promising crop when during the period of flowering and grain formation. Then, when grains are forming, slight heat wave shrivel the grains, so that the whole effort of the farmer goes with the shriveled grains, the quality is reduced, farmer won't get the money. For which the agrometeorologist should take the responsibility requesting the weather forecaster. Then a heavy shower rain or hail at the time of harvest completely vanishes. So we should give forecast to the farmer when are the what are the days which are free of hail. Then, if warned in time, the farmer would hurry up his harvesting operations if hails are there. So later, when the harvested crop is lying on the ground or threshing floor, it is again on the mercy of the sudden changes in the weather. Here also, timely warning helps the farmer a lot. So, all these things, starting from germination to emergence to crop establishment to vegetative to reproductive to harvesting to transportation, threshing in the floor and transportation, photothermal units, heliothermal units, thermal use efficiency, GDD, HTU, PTU, these are all very useful because once we calculate when those many days are there for each crop, that's what I call them as the weather health indices. If the crop is passing through the optimum conditions of these units, then we need not take. If otherwise, we should go for management options or technological intervention so that the farmer gets the best yield. That's why agrometeorologists must and should know all these basic. Innumerable of my students have worked in different theses, including these things I have mentioned in my principles and practice of agriculture disaster management, and the same things I have mentioned in a book which I wrote along with my students, Practical Manual on Agrometeorology. Thanking you for your patient hearing. May God bless you.